Hey, so I'm going to try and do a first episode or chapter of some programming, some graphics programming tutorials. So the first thing is that I'm going to start Visual Studio and I'm going to create a new project. And it's going to be an empty project. And I'm going to do it here in my programming directory, and I'm going to call it, I don't know what, I'm going to call it like intro graphic. Well, this is going to be about ray tracing fundamentally and eventually path tracing, but I'll just start with like the very, very basics of how to get set up and so on. So I'm going to call it, I don't know, I'll just call it ray tracing. I'll just call it ray tracing. I guess I'll make a little directory here for it, and this thing creates a little thing. So I'm going to add a new CPP file, and so this is where it, so that's the solution directory. I'm going to make a new directory for the source code. This is kind of like what I always do when I get this stuff going. Make a little source file, and I'm going to call it main. All right, so this is kind of how I usually start my projects. Int main, and I think it's like char argv, which is the string argument. C, which is like the number of arguments, returns 0. I hope that's correct. It will be so embarrassing if I start this off like on the wrong foot. And I mean, I do a bunch of little things here because I'm a Windows guy, so I don't use 32-bit Windows anymore. And so I remove all this x86 stuff. Right, and I give it a run. And yeah, I think the console window is going to spawn elsewhere. So this kind of does nothing. So the first thing that we want to do, I'll kind of explain the way that I'd like to start going about this. I usually try to just start from what I would call like the absolute minimum, which is like this is like a console application. And so the way that I would start writing images from that is to use this awesome little library. And you know, I don't like to use Qt or anything huge at the beginning. And this STB image is a wonderful single file header library that lets me just use this thing directly. So it lets me save, there's nothing to like build or include or anything like that. So I'm just gonna take the single header file, stick it in the source directory. And with that, then I will include it. And if we go into this file, then we see that it says before including hash define this dude in the file that you want to have the implementation. So I'm going to do that here. Oh dear, well, thanks. There's somebody watching in Discord. And because 0 can be both a char star and an argc, yeah, I got that the wrong way around. That was pretty embarrassing, but yeah, thanks Peter for catching that. All right, so yeah, let's run this, and it's again just gonna do nothing. So I need to first explain like what I would call the graphics programming 101, and because I'm kind of ghetto, I will do this in MS Paint. So I'm also going to, because I just don't like working on a black background, I'm going to make this thing kind of gray. I'm going to gray this thing out. So now I need to explain how images are stored in memory. And this is why the first tutorial is kind of like a little bit boring for most people, but I'm just going to do it anyway. So I'm going to make like a 4:3 image. And this will hopefully show the indices of the pixels. So the way that images are stored normally, canonically, is you have something like 0, 1, 2, 3, 4, 5, 6, 7, Okay. So basically, it's kind of the same as like your reading order. You go left to right and top to bottom. And the point is that memory in a computer is one-dimensional, but like our images are two-dimensional, right? So we need to convert a two-dimensional XY coordinate into a one-dimensional index. And the way you do this is, well, first of all, is that you note, I mean, like you go left to right and top to bottom, but there's like a pattern that you can notice is that first of all here, you see that the first index is zero. The first index of the first row is zero. The first index of the second row is four, and then it's eight, and so on. And so you see that the width is four pixels wide. So 0 times 4 is 0. 1 times 4 is 1. 2 times 4 is 8. And so we get a formula for, like, given a y coordinate, you know, what is the starting index of that row? So we can skip down y times the width. And then once we have that, we need to add the x coordinate. So for example, if we have like the coordinate, let's say 1, 2. I drew that 2 not very well. This is what I was worried about. I'm using a mouse. It's a bit ghetto. So this is y equals 0, right? So we're skipping that. So the starting index here is 4 at the beginning of the row. So it's 1 times 4, and then you see we need to go 2 to the right. So it's like plus 0, plus 1, plus 2. So that's like 4 times 1, I didn't draw that super well, times 1 plus 2 equals 6. And that gets us like over there. Right, so I mean, this might all seem a little bit obvious, but in my opinion, it's very important to get this like right, because a lot of times what people do is that they will like, okay, so let's say that we're going to do a for loop, and I mean, I assume that you guys know a little bit about programming, so I'm going to do the wrong thing first, right? Just emphasis on it being a wrong thing. I'm going to make a constant xres. Let's do like 1024, and yres is equal to 640. What a lot of people do is that they go like, they basically, they do this. And this is kind of going to give a flavor of the way that I'm very detail oriented about my graphics programming, and I think that I'd like to convey some of this in these tutorials. So I'm going to need to make some storage for this thing, and I'm also going to need some kind of, this is for like uints and so on. So std vector, this is just so that I'm going to store my image as RGBA, which is 8 bits per channel and 4 channels. So 8 times 4 is 32 bits. So I'm going to have xres, yres of those. I could initialize it to 0, but I'm not going to, because in the subsequent for loop, I am going to initialize all of them. So here, what I'm going to do is, well, I need my formula. And the way you saw this is that, like, to go down a column, I need to multiply by the width, right? And the width is 4 here, but that's like xres in general. And then to offset from the start of the column into the row, I need to add the x coordinate, right? So that's y times xres plus x. And I'm just gonna set it to 0 for the beginning. Why there's oh yeah. Why is this? Yeah, maybe it would help if I put a semicolon there. So this is going to set that element to 0. And there's a problem with this, and this is why I was saying that it was wrong. If you follow this loop, this is the first like attention to detail thing that we want to do in graphics. If you follow this loop, it's going to start with x, and then it's going to go from 0 to the width. And the problem with that is that the inner loop is going to be over y. So that means it's going to start here, it's going to start at this one, and then the next one it's going to go down here. And you see the index jumps from 0 to 4, and then it's going to jump from 4 to 8. And this is bad because in memory, in basically all graphics programming memory, simplistically, we'll can talk later about GPU formats and so on. But like in normal memory, where this stuff is stored in what is called row major order, we're jumping around a lot in memory, and it might not be so bad if we only have a width of 4, but if the width is like, I don't know, 1920, then we're going to skip over a ton of memory every time we go to the next pixel. And that's bad because the CPU wants to write memory in linear order. So a lot of people, just because like x comes before y alphabetically, doesn't mean that that's the order that we should do our loops. This is very bad for it doesn't access memory sequentially. So what you need to do is have the innermost loop must be the ones over adjacent memory. So if you do it this way, then it goes from 0 to 1 to 2 to 3 and so on, instead of going, you know, like that and then to here and then like that. So that's an important thing. So I'm gonna show you how to save. Like, first of all, let's write the memory out. Let's write the data out in the right order. And then let's see what kind of image we get out of it. So the way that data is stored in memory, and you know, I haven't prepared for this at all. I think it's ARGB. It might be RGBA, or we're gonna work this out now. So this is the thing, like I encourage you to kind of, don't try to memorize any details of what I'm talking about. Let's like show how to figure it out, and let's write this thing out. So the main thing that this STB ImageWrite gives us is that like it gives us an easy way to turn this array into an image. So I think it's like something like STB write PNG. Yeah, here we go. Here we go. Write PNG. That's what we want. We're gonna give it a file name. I don't know. Let's call it blah. PNG, and we have the X resolution here, the Y resolution there, and like I said, this is a UN32, and that means there's 32 bits per pixel, and that means there's 8 bits per channel, which is a very standard RGBA or ARGB format. So there are 4 channels. Even though you don't need alpha, we're just going to use it for now. You can change it later. And I mean, I assume you know a little bit of C++, so we're going to get a pointer to the first element, which is going to be image of 0, because a vector stores the stuff contiguously. And the number of bytes in the stride is like just the number of bytes per column, which is xres times 4, because we have 4 bytes per pixel. So this is going to save a black image, and that's fine, but we'd like to figure out how to, like, we want to make sure that our channels are working correctly. So we want constant R equal, let's try saving a red image. And we want to have an alpha of 255. So we're going to, the alpha 255 basically means that there's no transparency. And I believe the way this works is that the alphabet comes at the highest, the alphabet is at the top. So actually I think it's like this. I think it's ARGB. So the alphabets get shifted up, and this is some bit shifting stuff. I mean, if you're not comfortable with it, then yeah, I don't know, like you're just gonna have to look it up. But this is like kind of not the time for me to get into like bit shifting stuff. RGB, did I get that right? Why is G? Oh, right, RGB. Oops. Okay. So now, if we do this, I think we should expect So it did nothing, and what we're going to do is we're going to check out this thing, and we're going to look here into this blah. Yeah, you see that we got a blue image. So basically I was quite wrong with the order of this thing. So we were expecting a red image, but we got a blue one. So actually, I think it's like BGR. And that means the lowest bits are from red. So it's RGBA actually. So the lowest bits are R, the middle bits is green, then it's like blue, and then it's A. So let's verify our theory by running it again. And now we go in here, we look at this guy. Yeah, he's red. Okay, so let's confirm that again just by like, I don't know, we want, let's have like, I don't know, 64 of red and lots of blue. What is that going to give us? Red plus blue is like kind of like a purplish color, I guess. So if we open this up, where the hell is it? Yeah, it's kind of like a purplish color. So that's kind of like how you get started with the graphics programming. We're defining an image resolution, we're making a buffer for it, and then we're looping over the X and Y bounds, and we're sticking the bits in the right place. And then we're going to call this like library function. I mean, like PNG writing is a complicated thing. It's going to be like, I wouldn't like to try and write all of this stuff. I don't know how it encodes any of these lines or anything like that. So fortunately, that's kind of like done for us. But the point is that if we put the stuff in the memory in the right order, then we can just call this like library function. This thing actually returns something which I'm not using. It returns like the number of bytes written or something like that. So we should probably check that for error checking, but we're not going to do any of that. So that's the, I would say like the zeroth tutorial. It's like how you start an absolutely empty C++ project. And we're going to write the bytes into memory into the correct order. There's another way that you could have done this, you know, instead of using UN32, we could like have, fine, let's do a little bit of bonus round. Let's do like struct it's ARGB. Yeah, let's just call it that. And then we have uint8t, I believe is what it is. And the highest byte goes, I think this is like in byte order. So I think it goes like B, and G, and then yeah, RA. So I think we could do this. And then we could go, let's comment this out. And let's go ARGB pixel color. I do color with a U because I'm a former British colony. So let's go like R equals 64. Yeah, well, let's just copy that. And then we can do this. Oops, like that. And then hopefully, well, yeah, we need a UN32 out of this. So this is, I mean, like, don't think too much about what I'm doing here. I'm going to stick all of this in a struct. And I'm going to make UN32T ARGB all in one. I don't know if that's going to work. Yeah, I don't know. I'm just V. Yeah, fine. Not the nicest naming. And I hope this works. I mean, I don't know why I'm kind of showing this, but it's just like to make sure that we get. Why does this not work? It's a UN30. Oh, right. Well, I didn't need to do any of that stuff. Lol. I mean, there are just multiple ways that you can access the same data, and so if we now open this up, I hope that it does the same. I hope that it looks the same. No, it's not. I've got the stuff in the wrong order. So I guess A is at the top, and then oh god, and B, G, R like that. But that would also suggest that we are writing this in the same. I'm kind of just embarrassing myself now. None of this really matters. Yeah, I've got it completely wrong now. It's still completely wrong. So B and R need to be swapped. RGBA. Right. Okay. Oh god, I still got it wrong. I'm gonna cut all this stuff out. Anyway, that's it for this first tutorial. Hope I sufficiently showed how to save these pixels. Kind of failed at the end, but whatevs. Gonna end it there for now. Thanks for watching. See you later.